which is the fracture half length and the fracture permeability and how many fractures up and low of that perforation is being perforated. So for that, we will go to this hydraulic fracture option, then planar fractures, then templates. Again, template and click on these. So the fracture half length parameters is this BWHLEN. That is initially it was given 55 value, and we will click add this and rename this as fracture half length. Now you can also see that I cannot give any space while naming these parameters because that will create an error. But if you give that, the CMOS will automatically add an underscore in that name because it cannot give the name as in terms of space because this has to be one keyword. So this K1 int is the permeability of that fracture. So let's name this also as fracture permeability. And then the how many layers up and down is being fractured along with this layer. So this is fracture layer up. And this is fracture layer down. So the parameters for the fracture have been added. Now we will add, we also have to add a permeability parameter for the K direction. But for K direction, instead of giving a same value, creating a parameter, what we are doing, we are giving it, we will be giving this as a function of permeability in the horizontal direction. But that I will show in the later stage. At present, we only have to create the parameter for this. So this is permeability in vertical direction. Now we will be adding the parameters for the rock properties, that is for the core correlations. So to do that, we have to select this builder keyword option and select the relative permeability tables and rock type, and then go to that set one and show data. So here all that data that was used for creating the relative permeability data is there. Instead of doing this, we can also do is we can import two or three relative permeability steps and import those data in the rock weight section. What is the relative permeability data? We can give the address of that file or that Excel file. But in this case, we are using the builder option because it will be more easy and the data set which will be created will be much more. So in this, like only the data can be seen, but if we remember, we have given the current water saturation, critical water saturation, and the relative permeability of oil at critical water saturation, relative permeability of water at critical relative permeability of water at critical oil saturation. So all those parameters was there, and to see the keyword, we can click on this, and it will show that this 0.19 value is for SW con, that is current water saturation. This 0.19 again is for the critical water saturation. So if we do not know which value was for which, we can click on that and see for which the like which value is for which parameter. And here we will be creating the CMOS for these few, and we will be creating for like SG critical, that is the critical gas oil. So this is SG critical. For connate gas saturation also, we will be using the same the value that will be given for SG critical, that is the critical gas saturation. We are also changing the value of residual oil saturation for gas table, so that is this 0.15. And we are using the residual gas saturation also the same. Then R for the critical saturation of gas in at critical liquid saturation. Also, we are using this. We're making the parameter for that. And apart from these four, we will be changing the values of the exponent component, the exponential components for the gas table. So I think these are the two. So in this, like when changing the, like when checking for the relative permeability table, we are only like mostly changing the values which is for the liquid gas table, because we can water oil ratio and the gas oil ratio and the cumulative gas and the cumulative oil was having much more error. So that's why we are only selecting like and mostly selecting the parameters that are relevant to the gas liquid table. So we'll click on OK, and this asks whether the master data set has need to be modified, and we will say yes, and we will override this. And again, so now when we click on import, all the parameters for which we have created we have created then we have given the names, those all are imported here. So now in this section, what we have to do, like for compressibility, if we want to check from a particular range, let's say if we vary this compressibility from, let's say, 1 e raised to the power minus 6 to 1 e raised to the power minus 5. So by giving these upper and lower limit to the compressibility, what we are telling this CMOS is to select 11 values from these two limits and create the data set for that values. Okay, so that is, and in usually like when if we are not using CMOS, we will have to create the data set for those value by our own. But this CMOS will just see the upper and lower values and the number of values that has to be created, and automatically create the data set for that for this parameter, and we do not have to like open a builder file and copy that data set again and then open again to change the parameter. So that lengthy process has been very much reduced by using this CMOS. So for this fracture length, also like for fracture length, what, let me see, yeah. For fracture half length, we are selecting the values from 20 to 70. And you can also see that we have selected this compressibility and fracture length to be continuous and real. But this won't be possible for this layer down and layer up parameter because it won't be possible to have only half layer fractured. We can only give that the entire layer fractured. So for that we will select go on the source option and then select discrete integers, and we will enter the values which we think can happen. So let only 0 or 1 or 2, 3 or 4. So now when the CMOS will make the model for these using for these parameters, it will only select either 0, 1, 2, 3 or 4 as its values. Similarly, for the layer up also, we will be selecting the discrete integer. These lower and upper bounds which we are giving for these different parameters, it will vary depending upon the reservoir simulation engineer. Like maybe he can give a much narrower limit, or he or she can give a much larger limits. So this actually depends on using the CMOS. And by specifying these upper and lower limits, the simulation engineer must also know what values has to be given. Like in this KR OCW, by default, it was showing 1.25, which is not possible in real life scenario. So it must be taken care that the values which are given for lower and upper limits, that must actually, like that can actually happen. It cannot be like any value which the simulation engineer wants. So this care has to be taken while specifying the lower and upper limit, or else that model will be created, but that will like ultimately give error while running the models. Okay, so for this permeability in the V direction, what we are going to do is we will specify that in terms of the permeability in the horizontal direction. So for that, what we have to do, we have to create a, like we can simply insert a new parameter, and we can say this as permeability in the H direction and permeability in the V direction ratio. Now we can give this the value of for this as 0.05 to 0.5, and we can give any other value also. because we will be using these values and for assigning the relation between the horizontal and vertical permeability. So for horizontal vertical permeability, we will now have to use a formula. So we will select the formula from this source option. We will simply write that this vertical permeability is now permeability in the h direction multiplied by KH KV ratio. So for any model, like say if the permeability of the H, permeability in the H is taken as 0.24 and the ratio is taken as 0.5, so permeability of V in the vertical direction will be automatically 0.24 multiplied by 0.5, and that will be incorporated in the as the permeability in the V direction. So we can interrelate those things, like give the parameters as formulas, and the CMOS will automatically calculate what values has to be incorporated. So for porosity, we are leaving the default values for the critical gas saturation 0.01 to 0.06, and for residual gas saturation 0.05 to 0.25. So we have given the upper and lower limit for all the parameters, and this would be a very good time to save this study. Up to this, anybody have any confusion or any questions? Okay, so I believe there are no questions. So next step is that we have to, like, we can give all other, like for hard constraints also we can add some constraints. In the well and recurrent option also we can add some information regarding the well and recurrent events. Like if we want, let's say well is being closed after 6 months, and we want to see whether what will happen if it is closed instead of closing at in 6 months, it is being closed at it is being shut down and at in 7th month or 8th month or 9th month. So that option or that variation in the well parameters can be done in this well and recurrent section. Next is this pre-simulation command. So here we will be adding this option, that is in we will click insert and we will select this run CMG builder silently. And this is very important in this case because of the relative permeability data which we are giving. Because not because of the relative permeability data, but because we are using the Fourier correlation, and the relative permeability data has to be generated using the Fourier correlation, and that can be done by builder only. So that is why this run builder option has to be selected. If we will not select this, then the relative permeability data which is in the base file, that will be automatically used, and the variation of the relative permeability will not be done. So here this we will select this, and by default this builder path is already selected. So next we have to go to the objective function. In objective functions, we will go to this basic simulation results, and we will click on add, and here we will add those parameters for which we want to see the results, like see the results of how these change in the parameters is affecting these particular uh, parameters. Like we will add as cumulative oil, and for origin we will like select which parameter we are using, that is the cumulative oil. Similarly, we will give a name cumulative gas, and select its origin as cumulative gas for this well, and we will can select gas oil ratio and select the source as gas oil ratio for this well. So these basic simulation results will actually like you can say that we are looking toward these parameters and how these parameters like not parameters how these results will be affected by the parameters which we have incorporated in the previous step. So this is like other values we can also give, but in this only this is required. And then we will go to the control center. So input part is over, we can simply minimize it. So in control center, we have to go to the simulation setting, no, engine setting. And here we will select what kind of, like we have already selected sensitivity analysis in the previous part, and we will keep this as default. And then we will select what kind of study we want to do. Like do we want to study each parameter at a time? Like one parameter at a time means that one like when porosity is being varied and the other parameters will assume its default value, and when the permeability in the let's say horizontal direction is being changed, the other values, the other parameters will remain same. So that is called as one parameter at a time analysis. And second option is to select the response surface methodology. Now response surface methodology means in this what is done is a set of uh, for porosity, one parameter, one value of that parameter will be selected for permeability, another parameter will be selected for, and it creates a set of parameters can be used to see the interaction of the two parameters as well as study the effect of each individual parameters also. So we will select this, and other we can keep the values as default. Then we will go to the simulation setting, and here we will select this local because other options we are not using, and we will be using the we will be running the simulation in our own system. This we can increase based on our system capability. So I'm selecting 8 at this point. But if you have like a quad core processor, or if the computer is not that much capable of running simultaneous studies, we can reduce this to 4 or to 1 also, and others we can keep in default options. So this is also okay. Now the experiment table, we will go to experiment table, and now this right click on this and resolve this uh, selected experiment. Now, because we have introduced independent KH versus KV ratio, and that value is not given in the default parameter, default or the base data set. That is why we have to resolve this effect, and we can give like 0.25 for starting. And click on OK. Now this you can see like no cross option is there in experiment table also. And if we have not given this KH by KV ratio, and we would have given a separate a set of range for the vertical permeability, we might not have to do this, but this is just an optional step, and it will depend on our study whether we have to do this or not. Then we will go to the control center and click on this green start button. Okay, I think there was some error, has not been declared. Okay. So there was just a spelling mistake here. So now I think we are good to go. Okay, so now our study has started, and now it will create around 47 or 50 sets of data set, and it will simulate, and we will see how the results are varied upon changing the parameters. to see the results up to this point, like I don't think at this point any result will be shown. Okay, so you can see like one data set has been created and that result has been done. Now one more data set is being created. And we can see the results here. Okay, no, let it run for some time and then we can see the result. Okay, so by the time these experiments run, we can take a break and we will join again at 11 a.m. and then I will show you the results because these usually take some time to run and process all the results. Okay, so we will continue in at 11.